Hello friends, I'm Vishnu Maurya. In this video, we will quickly revise the subject building material and construction, the first topic, that is bricks. In the upcoming videos, I will upload the other topics of the building material and construction, and first of all, we will discuss bricks here. In the bricks, we will discuss the constituents of good brick earth, harmful ingredient in bricks, manufacturing of the bricks, classification of the bricks, and the testing on the bricks. Okay, so first of all, we will see what are the bricks. Bricks are the most commonly used construction material. Bricks are prepared by molding clay in the rectangular blocks of uniform size and then drying and burning these blocks. So you are very much familiar with how the bricks are prepared, and these are the most commonly used construction material. The standard dimension of the bricks is 190 by 90 by 90 mm, and the standard brick weight is 3.5 kg approximately. But the brick weight in India is approximately 3.1 kg, and the dimension is 215 by 102.5 by 65 mm. Okay, so these are the two dimensions, and we have mostly we have to memorize this dimension because these are frequently asked in the examination point of view. Now, what are the constituent of good brick earth? This is the very important topic, and the constituent of brick earth are silica, alumina, lime, iron oxide, and magnesia in the preferential order. Okay, so first of all, silica is the maximum amount of content that is present in a good brick raw material. Okay, in the good brick earth, the brick earth should contain about 50% of the silica, and the silica is responsible for preventing cracking, shrinkage, and warping of the raw bricks. Okay, so silica is very much important. Silica is the basic constituent of this brick, and this is important for preventing cracking, shrinkage, and warping. This also affects the durability of the bricks, and if the silica is present in excess, then it destroys the cohesion between the particle and the brick becomes brittle. Okay, so in the particles of the brick, the cohesion is destroyed. Okay, if the cohesion is destroyed, it will not be that much functional, and it will become brittle, and it may break down early. Now the alumina is the second most abundant material in the good brick earth. Good brick earth contains about 20 to 30% of the alumina, and it is responsible for the plasticity characteristic of the earth. Okay, it is responsible for the plasticity characteristic of the earth. That is why it is important in the molding operation. It leads to the joining of the different material into the brick. Now, if it is present in the excess, then the raw brick shrinks and warps during drying. Okay, so the presence of alumina is also in the excess is also undesirable. Now the lime, if the lime is present in 5 to 10%, then it is very good for the brick earth, and it is very much responsible because it prevents the shrinkage of the bricks, and it causes silica in the clay to melt on burning and thus helps to bind it. So it acts as a binding material for the silica in the clay in the production of the bricks. Okay, now if the excess of lime is present, then it may lead to the higher amount of the binding material, so it may lead the brick to melt and the brick loses its shape. Now the iron oxide is present in 5 to 10% in the good brick earth. It leads to the color of the bricks as red color. You can see it is also a red color compound, and it improves the impermeability and durability of the brick. It gives strength and hardness, and if it is present in excess, then the color of brick becomes dark blue or the blackish. Okay, so excess of iron oxide is undesirable, and if the quantity of the iron oxide is comparatively less, then the brick becomes yellowish in color, because it is red in color, and the red color will be in scarcity. Now the magnesia in the good brick earth should contain a small quantity less than about or approximately 1%, and the magnesia in the brick earth imparts the yellow tint. It provides the yellow tint to the bricks, and it is responsible for reducing the shrinkage. The only benefit is it is responsible for reducing shrinkage in the brick. The excess of magnesia leads to the decay of the brick. Now we will see the harmful ingredient in brick. Harmful ingredient is first of all lime. Lime in the presence of excess, we have already seen it. Small quantity in the lime is required in the brick earth, but if it is present in excess, it causes the brick to melt, and hence brick loses its shape. Okay, if lime is present in the form of lumps, it is very much harmful because it can combine with moisture, and it can cause the splitting of the bricks into pieces. Now, iron pyrites, the presence of iron pyrite in the brick earth causes the brick to get crystallized and disintegrated during burning because of the oxidation of the iron pyrite, and it discolorizes the bricks. The alkalis present in the brick in the form of soda and potash, it acts as a flux of in the kiln during burning, and it causes the bricks to fuse, twist, and warp. Okay, so these are harmful for the bricks. Because of this, bricks are melted and they lose their shape. In this, when the bricks absorb the moisture, then we can see a process of efflorescence. Efflorescence can be seen here. These are the white patches. When the bricks absorb the moisture, then these alkalis comes to the surface and they form a white patches on the surface, which is called the efflorescence because of the presence of the alkalis. Now, the pebbles are also the harmful ingredient. Pebbles in the brick earth create problem during mixing operation, and because of this it results in a weak and porous bricks after burning. So it contains the if the pebbles are present, okay, then the bricks will lose its shape as per the requirement. Now, the vegetation and organic matter, actually these are the carbonaceous matter. These contain the carbon content in it, and it when it burns, it leads to the black color into the brick. Okay, so the presence of vegetation and organic matter in the brick assists the burning, but if such matter is not completely burned, the bricks become porous. The bricks become porous because of the vegetative matter, and this is due to the fact that the gases will be evolved during the burning of the carbonaceous matter, and it will result in the formation of the small pores. Now we will see the manufacturing process of the bricks. Okay, there are four processes. First of all, preparation of the clay, molding, drying, and burning. Okay, we will see these one by one. First of all, preparation of the clay. In the preparation of the clay, first of all, we will do the unsoiling. Okay, these are the sequence of the operation: unsoiling, digging, cleaning, weathering, blending, and tempering. Okay, first of all, unsoiling. In the unsoiling, for top 15 centimeter layer of the earth is scraped off, and then the material is taken out from the earth, that is the clay particle is taken out, and these are done by digging. Okay, by digging, and then sieving, that is the cleaning of the of the raw material or the clay particles in the uh, dried form, and then we will lead to the weathering of these raw material. In the weathering, we will leave it for the environmental impact on it for some time, and then the blending is done. In the blending, some material are mixed with this raw material, and these are then go to the tempering in which the kneading operation is being performed. Okay, so after the kneading operation, we get the proper clay which is ready for the mold. Now, in the preparation of the mold, there are two processes, either hand molding or the machine molding. In the hand molding, you can see these are done by the hand, and we have the mold here in which we place the needed raw material of the good brick earth. And in the machine molding, this operation is totally performed by the machine. Obviously, this will be a better choice than the hand molding. Now, in the hand molding, you can see here either there will be ground molded bricks or there will be table molded. In the ground molded, we can see these are grounded on the mold, and in the table we perform the operation on the table. This is better in the perspective of the quality than this hand molding, or sorry, the ground molding. Now, in the machine molding, there can be plastic clay machine or the dry clay machine, in which this operation of the molding is performed. You can see the machine here. Now, in the process of the drying, the damp brick, if burnt, are likely to be cracked and distorted. Hence, the molded bricks are dried before they are taken for the next operation of the burning. Because of the presence of the moisture, it may lead to the crack and the distortion. So, first of all, the moisture is removed from the raw material of the brick, and then it is being taken for the operation of the burning. Now, for the drying, the bricks are laid longitudinally in the stacks of the width equal to the two bricks. The bricks are allowed to dry until the bricks becomes leather hard of the moisture content about 2%. Okay. Now, in the operation of the burning, there can be clamp burning or kiln burning. In this, clamp burning is also called as pazawa, or some small units, and in the kiln burning, these are done in the large unit of the bhatta or chimneys. Now, the bricks are burnt at the high temperature to gain the strength, durability, density, and the red color appearance. All the water removed at the temperature of 650 degrees, okay, up to 650 degrees all the waters are removed from the bricks. But after that the operation is taken up to 100 and 1100 degrees, because of the fusing of the sand and the lime takes place at this temperature only. Okay, so up to 1100 degrees what happens, fusing of sand and lime takes place, and a chemical bonding is taken between these materials. After the temperature is cooled down, resulting in the hard and dense mass. Now you can see the clamp burning here. Clamp burning, in this we can see here, clamp is temporary structure generally constructed over the ground with a height of about 4 to 6 meter. Now it is employed when the demand of the bricks is lower scale and when it is not a monsoon season. Okay, in the monsoon actually it is above the ground, so in the monsoon season it will lead to the improper burning, or it may lead to the low quality bricks production. And disadvantage of clamp burning is bricks at the bottom are overburned, and at the top these are underburned. Bricks lose their shape. Okay, and method cannot be employed for the manufacturing of large number of bricks. You can see here, this is for the small number of bricks only, and it is costly in terms of the fuel because of the large amount of heat is wasted. It cannot be employed in the monsoon season also. Now in the kiln burning or at the bhatta, you can see the kiln is a large oven used for the burning of the bricks. Generally, coal and other locally available material like woods, cow dung, etc. can be used as fuel for the kiln. So you can see here the kiln are of two type, either intermittent or the continuous. In the intermittent kiln, these are the operation is loading, unloading, cooling, and burning of the bricks. Okay, so this is intermittent process in which first of all a stack is being taken into the kiln, and after the total operation of the burning it is taken out. In the continuous kiln, this operation is done simultaneously. uh, Feeding is done from one side, and drawing of the fire brick is taken from the another side. So there are two examples of the continuous kiln, Bundstrench or Hoffman kiln. Okay, you can see the example here. This is Hoffman continuous kiln and this is Bundstrench kiln. Okay, now the classification of bricks as per the common practice. There are four kind of bricks in the common practice: first class, second class, third class, and fourth class bricks. We will see here one by one. First of all, the first class bricks. First class bricks are of the standard shape and size after burning operation, and the surface or the edges of the bricks are sharp, square, smooth, and straight. Okay, so you can see in the picture also the sharp, square, smooth, and straight shape of the bricks are the first class bricks. This color is completely red. Okay, and this comply with the all qualities of the good brick. The brick are used for the superior work or the of the permanent nature. Now second class bricks, these are the bricks ground molded. First of all, these are ground molded and burned in kiln. Okay, the surface of these bricks is somewhat rough and the shape is also slightly irregular. These bricks may have their hair cracks and their edges may not be sharp and uniform. These bricks are commonly used at the places where brickwork is to be provided with a coat of plaster. Okay, so these bricks cannot be exposed, and they are first of all they are provided with a plastering surface on it. Now third class brick, these bricks are ground molded and burned in clamps. Okay, so these are used for small works. These bricks are not hard and they have rough surfaces with irregular and distorted edges. Okay, now these bricks give dull sound when stuck together. Okay, in the test of soundness these may get fail. They are used for the unimportant and temporary structure and at places where rainfall is not heavy. Now the fourth class bricks. These are the overburnt bricks with irregular shape and dark color. These bricks are used in aggregate for the concrete in the foundation, floors, road, etc. So these bricks are not used for any structural purpose, and these are just used as an aggregate or something. These have a compression. Okay, and now we will see the classification of bricks as per the constituent material. First of all, these are common burnt clay bricks. Okay, these are normal bricks which we have already seen. There are sand lime bricks of calcium silicate bricks, engineering bricks, okay, of specific qualities, concrete bricks manufactured by concrete block, and fly ash bricks which contain fly ash in it. Now these fly ash bricks are very much used in operation in the urban areas. Now we will see the test on the bricks. We will see the compressive strength, water absorption, efflorescence, hardness, size shape, soundness, and structural test. Now First of all, we will see the compressive strength test, in which we place the bricks horizontally on a CTM, that is compression testing machine. Okay, in this usually we take the 5 specimen for this operation, and we do perform the compressive strength test. Okay, these results are taken as compressive strength. Now water absorption test, in which we take the sample of the 3 sample of the bricks, we place it in the water for 24 hours. Before placing it, we take the weight of it. After taking it out and leaving it for some times, we will again do the weight of it, and we will see how much water is absorbed by it. Okay, the percentage of water absorbed should not be more than 20% for the good brick. Now efflorescence test, in which we place the bricks like this into the tray, and which is filled with water, and we place it for 24 hours, and we will see the efflorescence on the surface of it, that is the white patches. If the white patches are not visible, then it is a good brick. If it is visible for about 10% of the brick surface, then the presence of alkalis is acceptable range. If it is about 50% of the surface, then it is moderate, but if it is over than 50%, then the brick is severely affected by the alkalis and they cannot be used. Now the hardness test is done by the scratch of the brick with finger. So you can see that this example is also given into the picture. In this case, the scratch is made on the brick surface with the hard thing. If that doesn't left any impression on the brick, then that is good quality brick. In the test of size, shape and color, okay, in this randomly 20 bricks are taken, okay, along lengthwise, widthwise and heightwise, and then these are measured and the variation is observed. These are given in the IS code of the brick, so you can take it from there. Now the soundness test is that the two bricks, they are being held in the both hands, and one in each hand, and they are stuck with one another. If the brick sound is clear metallic ringing sound, mind this word, clear metallic ringing sound, and don't break, then these are good quality bricks. Okay, so these are usually the side test which are performed to test the soundness of the brick. Now structure test is that in this test the brick is broken or broken bricks is collected and closely observed. If there are any flaws, cracks or holes present, then on the brick faces, then that is not a good quality brick. Okay, here we will finish with the subject brick. Okay, if you have any problem, you can contact me at windsofchange2020@gmail.com, and you can subscribe to my channel of Winds of Change. Thank you. You can find the PPT of it in the description of this video.